So we know, we just did, that the angle between two vectors is the inverse cosine of the dot product over the product of the magnitudes. We have three possible relationships for vectors. The first is that they are parallel, okay? Parallel vectors happen when the angle between them is either 0 or 180 degrees. So it will either be parallel vectors, either look like that, because that would be two vectors going in opposite directions, right? The angle between them is 180 degrees. Or they could be the same vector, and that would be 0 degrees between them, right? For orthogonal, that's a fancy word for perpendicular that we use with vectors. And orthogonal means the angle between them is 90 degrees. All other angles are just going to intersect somewhere, right? They're going to have some sort of angle between them that's not 0, 90, or 180. So let's think about orthogonal first. If I want the angle between the vectors to be 90, that means that I need the inverse cosine of something to be 90 degrees. Well, let's think about 90 degrees. What's the ordered pair at 90 degrees? 90's at the top, right, of our unit circle. So the ordered pair at 90 degrees is 0, 1, right? So that means that the cosine value must be 0, right? It's the inverse cosine of 0 that is 90 degrees. So how am I going to get u dot v over the magnitude of u times the magnitude of v to be 0? Well, my magnitudes can't be 0, right? That's the length of the vector. If there's no length, then it's just a dot, right? It's not a vector anyway, right? So the only way for this to happen is when u dot v is 0. So I know that two vectors are perpendicular or orthogonal if u dot v is 0. So if I just want to know if they're orthogonal or perpendicular, I can just check the dot product. And the dot product will tell me if they're perpendicular or not without having to find the magnitude and actually find the angle between them. What about parallel? Well, parallel, the inverse cosine of something is 0 or 180. Well, at 0, what's my ordered pair? 0's on the left-hand side of the unit circle. So at 0, we're at -1, 0. And at 180, we're at 1, 0. So we would need this to be a positive or a -1 to be able to do the inverse cosine and get either 0 or 180. So you would need the whole thing, the u dot v, over the magnitude of u times the magnitude of v to be plus or minus 1. And clearly that's going to be pretty rare, right? As will the 0. But you can see that it would be pretty hard to make all of that be a 1. Everything else is just the angle between them, okay? So our instructions say find the angle between the vectors and classify them as parallel, orthogonal, or neither. So again, parallel means that the angle between them is either 0 because it's the same angle, or 180 because they start in the same place and go opposite directions. And orthogonal means the angle between them is 90, and we get that pretty easily with u dot v being 0. So let's find the dot product here, S dot t. Product of the horizontal components, -5 times -6 is +30, plus the product of the vertical components is -20. So S dot t is 10. So I know they're not orthogonal, right? I can already cross that off the list because the dot product isn't 0. The magnitude of S, let's see, is going to be the square root of 25 plus 16, which is the square root of 41. The magnitude of T is going to be the square root of 36 plus 25. Again, we're just using the Pythagorean theorem, which is the square root of 61. So I'll call theta the angle between them. This is the inverse cosine of the dot product was 10. And then over the product of the magnitudes, square root of 41 times the square root of 61. Let's see, inverse cosine of 10 over square root of 41 times the square root of 61. 70, what do they want? Nearest degree, 78 degrees. Cool? Right? Oh, last question, it said, classify it as parallel, orthogonal, or neither. Well, this is neither, right? Because it's only parallel if my theta would be 0 or 180, right? And we know it's not orthogonal already. All right, so here let's do u dot v. 5 times 1 is 5 plus -5. Woohoo! That's 0, right? If u dot v is 0, we already know that theta is 90 degrees, which makes those vectors orthogonal. If you had gone through and typed in inverse cosine of 0, you would get 90, right?